What if I told you that the stone you just kicked aside on a hiking trail, or the small pebble you picked up by a river, could be one of the rarest treasures on Earth? Imagine holding something in your hand that was born over 1 billion years ago, deep within the Earth's mantle. A stone forged in conditions so extreme that it has survived volcanic eruptions, shifting continents, and millions of years of erosion, only to end up right where you stand today. For thousands of years, diamonds have been more than just gemstones. They've been symbols of power, love, endurance, and status. Ancient civilizations believed they were fragments of stars, fallen to Earth during thunderstorms. Warriors carried them into battle, convinced these stones could make them invincible. Lovers gave them as tokens of eternal devotion. Kings and queens locked them away in treasuries, while explorers risked their lives searching for them in uncharted lands. The diamond story is as much about human history as it is about geology. But here's the thing, when you find a diamond in the wild, it doesn't look like the sparkling gem you see in a jewelry store. There's no spotlight making it dazzle, no polished facets catching the light. Instead, it might look dull, coated in a layer of dirt or minerals. At first glance, you might even mistake it for quartz or just another ordinary rock. That's part of the magic. Nature hides its most precious creations in plain sight. In this journey, we're going to uncover how to recognize such a stone for what it truly is. You'll learn where diamonds come from, the incredible forces that create them, and the landscapes where they like to hide. We'll explore the tools and techniques that prospectors, from curious amateurs to seasoned experts, use to find them. We'll hear stories of remarkable discoveries, some made by sheer accident, others by years of patient searching. And perhaps most importantly, we'll reveal the signs that tell you when you're holding more than just a rock. So, as you listen, I want you to picture yourself in the field, crouched by the bend of a river, the sun glinting off wet gravel. Your hands sift through pebbles, your eyes scanning for something unusual. And then you see it, a faint, sharp glimmer that doesn't belong to any ordinary stone. In that moment, you realize you're not just holding a piece of Earth's crust. You're holding a story billions of years in the making. Long before humans walked the Earth, before the first forests grew or the first oceans teemed with life, deep beneath the planet's crust, something extraordinary was happening. About 150 to 200 kilometers below the surface, in the upper mantle, carbon atoms, the same element that forms the graphite in your pencil, were being rearranged by unimaginable forces into a new and perfect order. Here, under crushing pressures exceeding 45 kilobars and searing temperatures above 1,200 degrees Celsius, nature was crafting diamonds. This environment is unlike anything we can truly comprehend. Imagine a place so hot that rock flows like thick syrup, and so pressurized that the air around you would crush you instantly if you could somehow be there. It's in this hostile alien world that the atoms align into a crystal lattice, a structure so strong and stable that it makes diamond the hardest natural substance known to science. It's this perfect arrangement that gives diamonds their legendary brilliance and their ability to withstand almost anything. But formation is only the first chapter of the diamond's journey. For millions, sometimes billions of years, these crystals remain locked deep underground, far beyond human reach. They rest within the mantle, untouched, their sharp-edged shapes frozen in darkness. And then one day, in geological terms, something happens. Deep volcanic eruptions, far more violent than anything we've ever witnessed in recorded history, rip through the Earth's crust. These eruptions create narrow vertical channels, known as kimberlite pipes or lamproite pipes, which act like elevators for the diamonds. In a matter of hours, material from the mantle is blasted to the surface, carrying diamonds along for the ride. These events are rare, and they haven't happened in most parts of the world for tens of millions of years. In fact, many of the diamonds we find today were brought to the surface during eruptions that occurred over 1 billion years ago. Once they arrive, they're trapped within solidified volcanic rock, waiting for erosion to set them free. Over time, rain, wind, and rivers chip away at the host rock, washing the diamonds downstream into riverbeds, beaches, and even the ocean. This is why you can find diamonds in two very different places, In their original volcanic home, the primary deposits, or far away, where nature has scattered them over centuries, the secondary, alluvial deposits. A diamond's journey from the mantle to your hand is one of survival against staggering odds. Each one has endured extreme heat, unimaginable pressure, violent eruption, and the slow grind of erosion. When you hold a diamond, you're holding a survivor, a time capsule from a world far beneath your feet. And here's the thought that always gives me chills. The diamond you might one day find could have formed before the first multicellular life appeared on Earth. It could be older than mountains, older than continents, older than the very rivers you search beside. You're not just finding a stone, you're discovering a fragment of deep time, a witness to Earth's ancient past. When it comes to finding diamonds in nature, your greatest ally isn't luck, it's knowledge. The land itself tells a story if you know how to read it. Every hill, every bend in a river, every outcrop of rock is like a page in a geological diary, recording events that happened millions of years ago. And somewhere in those pages are clues that can lead you to diamonds. One of the first things prospectors learn is that diamonds are not evenly scattered across the globe. They are concentrated in regions where specific geological conditions existed in the past. This means your first step in the hunt is understanding the local geology. Were there ancient volcanic eruptions here? Does the bedrock in this region contain kimberlite or lamproite? Are there known placer deposits, places where heavy minerals have been washed downstream and settled over time? Kimberlite and lamproite pipes are the birthplaces of most natural diamonds. They appear on the surface as carrot-shaped formations of volcanic rock, often weathered down to gentle hills or depressions in the ground. In some places, these formations are exposed, but more often they're hidden beneath soil, vegetation, or younger layers of sediment. An experienced prospector will look for certain rock fragments on the ground, bits of blue-gray kimberlite or olive-green lamproite, that hint at what lies below. But geology is more than just rocks under your feet. It's also about water. Rivers are nature's conveyor belts, transporting material from one place to another. Diamonds, being incredibly hard and resistant to weathering, can survive these journeys for hundreds of kilometers. If you understand how rivers deposit heavy materials, you can predict where diamonds are most likely to settle. Look for inside bends where the current slows, behind large boulders, or in natural traps along the riverbed. These are the same places where gold prospectors search for nuggets, and for good reason. Heavy minerals, whether gold or diamond, obey the same laws of physics. Erosion is another key player in this story. Over millions of years, wind, rain, and frost break down mountains and expose the treasures hidden within them. In regions with a long history of erosion, diamonds that were once buried deep underground can now be found near the surface. This is why some of the most productive diamond fields are far from any active volcano. The original kimberlite pipes have long since been worn away, leaving only the stones they once held. Even vegetation can offer hints. Certain plants grow particularly well in soils rich in magnesium and potassium, the same minerals found in weathered kimberlite. Prospectors in Africa and India have been known to follow the growth patterns of these plants as a way of tracing hidden diamond-bearing rock. Learning to see these clues transforms the landscape. A hill is no longer just a hill. It might be the weathered crown of an ancient volcano. A gravel bar in a river is not just random stones. It's a trap where heavy treasures have been hiding for centuries. Once you start looking at the world this way, every walk through nature becomes a potential expedition. When you hear stories of people finding diamonds, they fall into two main categories: those who find them where they were born, and those who find them after nature has carried them far from home. Geologists call these primary deposits and secondary deposits, and understanding the difference between them is one of the most important steps in becoming a successful diamond hunter. Primary deposits are the source, the original vaults where diamonds formed and remained locked away until something set them free. In most cases, these are kimberlite pipes or lamproite pipes, narrow, carrot-shaped columns of volcanic rock that extend deep into the mantle. When you're standing on top of a primary deposit, you are literally above the birthplace of the diamonds in that area. The kimberlite itself often looks bluish-gray when freshly mined, though it weathers to a yellowish or brownish color at the surface. Inside this host rock, diamonds are scattered like hidden seeds in a loaf of bread, sometimes plentiful, sometimes frustratingly rare. Finding a primary deposit is the dream of every prospector, but it's no easy task. These pipes are relatively small in surface area, sometimes only a few hundred meters across, and often buried under layers of soil and vegetation. In many famous diamond-producing regions, from Botswana to Russia to Canada's Northwest Territories, geologists spend years mapping mineral indicators and conducting geophysical surveys before locating a promising site. But if you do stumble upon one, the potential is enormous. Secondary deposits, on the other hand, are where diamonds go after leaving their volcanic cradle. Once erosion breaks down the kimberlite or lamproite, the diamonds are freed and carried away by rivers, streams, glaciers, or even waves along the coastline. Because diamonds are dense and extremely durable, they can survive these journeys intact. Over time, they settle in places where water slows enough for heavy materials to drop out gravel bars, inside bends of rivers, behind boulders, or in the cracks and crevices of bedrock. These alluvial deposits can be many kilometers away from the original source. In some cases, the primary deposit has long since eroded away completely, leaving only scattered diamonds in river gravels. That's why some of the most successful diamond finds have happened in places with no visible volcanic rock in sight. In Namibia, for example, diamonds washed down rivers from Central Africa over millions of years before ending up along the Atlantic coast, where they are now mined from beaches and even offshore. There's also a special category of secondary deposits created by glaciers. In Canada and parts of northern Europe, massive ice sheets once scraped across the land, picking up diamonds from primary sources and dropping them hundreds of kilometers away when the ice melted. Prospectors in these regions study glacial till, the mix of rocks and sediments left behind, to trace the path of the ice back to its diamond-bearing origin. The difference between these deposit types changes how you search. Hunting for a primary deposit is like looking for the vault, the origin of wealth. It requires geological detective work, following indicator minerals and rock clues to pinpoint the source. Searching secondary deposits is more like panning for treasure in a stream. You're gathering what nature has already scattered for you. But here's the key takeaway. Whether you're standing over a volcanic pipe or knee-deep in a river, every diamond you find has already traveled a long and dangerous road. The fact that it survived the journey at all means it's tough, resilient, and ready to be discovered by someone who knows what to look for. If diamonds are the hidden treasure, then indicator minerals are the trail of breadcrumbs that can lead you straight to them. In the world of prospecting, these minerals are invaluable because they often occur alongside diamonds in the same geological environments. By learning to recognize them, you can drastically improve your odds of success. The most famous of these clues is garnet, but not just any garnet. Prospectors look for a variety called pyrope garnet, which has a deep red to purplish color and a chemistry enriched in chromium. This particular type of garnet forms under the same high-pressure, high-temperature conditions as diamonds, deep within the mantle. When erosion frees a diamond from its host rock, it often releases pyrope garnets too. If you find a concentration of these garnets in a riverbed or in glacial till, you might be following the same path the diamonds took. Another important indicator is chromite, a dense, black, metallic mineral that's rich in chromium and iron. It's much heavier than most common rocks, so it tends to settle in the same trap areas and rivers where diamonds collect, behind boulders, in crevices, or in gravel bars. Like pyrope garnets, certain types of chromite have a chemistry that points directly to diamond-bearing kimberlite. Then there's ilmenite, a black, shiny mineral with a metallic luster that contains titanium. Not every ilmenite deposit is associated with diamonds, but the presence of certain compositions, especially magnesium-rich varieties, can be a strong hint you're in the right territory. These indicator minerals work together like pieces of a puzzle. A single garnet might not mean much, but if you find garnet, chromite, and ilmenite in the same area, especially in abundance, It's a strong sign that a diamond source is nearby. This is exactly how professional geologists track down undiscovered kimberlite pipes. They sample river sediments for these minerals, analyze them under a microscope or with chemical tests, and then trace them upstream until they find the source. For the amateur prospector, knowing these minerals by sight can be just as valuable. In the field, a simple magnet can help separate magnetic ilmenite and chromite from lighter materials. A hand lens lets you study the color and shape of garnets. Even the texture of the sand and gravel under your pan can tell you if you're in a heavy mineral concentration zone. One of the most fascinating things about indicator minerals is that they often survive the same incredible journeys as diamonds. They can travel hundreds of kilometers from their original source, carried by rivers, glaciers, or wind-blown sediments. Following them is like reading a treasure map written by nature itself, one that only reveals its secrets to those who pay close attention. So, while everyone dreams of spotting that unmistakable diamond glint in the gravel, seasoned searchers know that the real skill lies in spotting what comes first. Find the right garnet, chromite, or ilmenite, and you might just be one step away from uncovering something far more valuable than a pretty stone. You could be standing on the trail to a diamond's birthplace. Finding a crystal in nature is exciting, but identifying it correctly is where the real challenge begins. A rough diamond in the wild rarely looks like the sparkling jewel you see in a jewelry store. It doesn't have neatly polished facets, and it won't necessarily shine brightly under the sun. In fact, at first glance, it might look disappointingly ordinary, like a cloudy piece of quartz or a chunk of broken glass. Yet, there are subtle but unmistakable signs that can help you tell a diamond apart from everything else. One of the most important characteristics is hardness. Diamond is the hardest naturally occurring material on Earth, ranking a perfect 10 on the Mohs scale. This means that it can scratch virtually any other mineral, but nothing, except another diamond, can scratch it. In the field, you might test this by trying to scratch a piece of corundum, such as sapphire, or even a steel blade. If your stone leaves a clear scratch, that's an encouraging sign, but be careful, as some synthetic materials and hard gemstones, like moissanite, can also pass this test. Shape is another clue. Many natural diamonds form as octahedrons. Imagine two pyramids joined at their bases. These crystals may have slightly rounded edges from river wear or show tiny growth patterns on their surfaces, but their overall form is distinct. Other natural forms include cubic shapes or flat, triangular crystals called macless. If you know what to look for, these shapes stand out from the irregular forms of quartz or feldspar. The luster of a diamond is also unique. Experts describe it as adamantine, a kind of bright, reflective sparkle that seems almost metallic. Even a cloudy or included diamond will have this type of luster when clean. This is different from the glassy, vitreous luster of quartz or the greasy sheen of some other minerals. Holding the stone up to natural light and rotating it slowly can reveal this subtle but telling glow. Transparency can vary widely. Some rough diamonds are crystal clear, while others are milky or even opaque. Inclusions, tiny internal flaws, are common and don't necessarily mean the diamond is low quality. Some inclusions can actually help confirm the stone's natural origin. Density is another key factor. Diamonds are heavier than quartz for the same size. If you hold a diamond in one hand and a similar-sized quartz crystal in the other, the diamond should feel noticeably heavier. Professionals often use a specific gravity test to measure this difference, but even a practiced hand can sense it in the field. Then there's the thermal conductivity test, one of the most reliable ways to identify a diamond. Diamonds conduct heat extremely well, much better than most other minerals. That's why jewelers use handheld testers that can instantly confirm whether a stone is a diamond or an imposter. While you probably won't have such a device on a casual outing, it's worth knowing that this property exists and can be tested later. Of course, there are imposters. Clear quartz, topaz, zircon, and especially moissanite can fool the untrained eye. Some of these have similar hardness and sparkle, but subtle differences in luster, weight, and crystal form can help you tell them apart. Ultimately, identifying a rough diamond is about stacking evidence. A single clue might not be enough, but when multiple signs line up, the shape, luster, hardness, density, and transparency, the odds grow stronger. And when that happens, your just a rock might suddenly become the most important find of your life. While diamonds can, in theory, be spotted with nothing more than a sharp eye and a bit of luck, the reality is that serious prospectors rely on tools, some simple, others highly specialized, to improve their chances. Whether you're wading through a river, hiking through rocky terrain, or sifting through buckets of sediment, having the right equipment can mean the difference between going home empty-handed and making a life-changing discovery. For the beginner, the most basic setup starts with a prospector's pan. Similar to the pans used for gold, these shallow, round trays are perfect for separating heavy minerals from lighter material. By swirling water and gravel together, the lighter sand is washed away, leaving the dense materials like garnets, chromite, and hopefully diamonds at the bottom. Alongside the pan, a classifier sieve is invaluable. This is a screen with uniform holes that lets you quickly sort material by size, making it easier to work efficiently. A hand lens or jeweler's loupe is another must-have. A good 10x magnification lens lets you inspect small stones for crystal shapes, luster, and inclusions, all the details that can help distinguish a diamond from an imposter. If you're going to spend hours hunched over gravel, this tool will quickly become your best friend. For those willing to invest a bit more, a portable thermal conductivity tester is a game changer. These handheld devices can instantly tell whether a transparent stone conducts heat like a diamond, making them one of the fastest and most reliable field tests. They're not infallible. Some synthetic materials, like moissanite, can still cause confusion, but combined with visual inspection, they're incredibly effective. Other useful items include a magnet, which can help identify magnetic minerals like certain types of ilmenite or chromite, important clues in locating diamond-bearing rock. A small geologist's hammer is handy for breaking open rocks and revealing fresh surfaces, while tweezers are essential for handling small crystals without losing them in the dirt. If you're in a remote location or dealing with large volumes of material, you might consider a sluice box, a simple channel that uses running water to separate heavy minerals from lighter ones. For the most dedicated hunters, there are even portable versions of gravity separation tables and spiral concentrators, devices that process large amounts of sediment with minimal effort. And let's not forget the non-mineral tools. A GPS device or mapping app for tracking promising sites, waterproof boots for wading in rivers, gloves to protect your hands, and sample bags for collecting material for later analysis. Even a notebook and pencil can be vital for recording where you found indicator minerals. Sometimes the real discovery comes after reviewing your notes back at camp. The beauty of diamond prospecting is that you can start with very little and slowly upgrade as your skills and dedication grow. A pan, a sieve, and a keen eye might be all it takes to spot your first stone. But with each new tool you add, you tilt the odds a little more in your favor. And in this game, where the difference between success and failure can be just a few millimeters of gravel, those odds matter. For many prospectors, rivers and creeks are the most exciting hunting grounds for diamonds. Waterways are nature's sorting machines, endlessly moving material from one place to another, concentrating heavier minerals in specific spots while carrying away the lighter, less valuable debris. Learning how to read a river is one of the most important skills for anyone serious about finding diamonds. The first step is understanding how water moves. In fast-flowing sections, the current has the power to pick up and carry even heavy materials, sweeping them downstream. But when the current slows, perhaps around a bend, behind a large boulder, or at the mouth of a side channel, the heavy stuff sinks and settles. These calm spots act like natural traps, catching gold, garnet, and yes, diamonds. When prospecting in a river, you want to target inside bends. As water curves around a bend, the inner side has a slower current, allowing heavy minerals to drop out of suspension and settle. This is the same principle gold prospectors use, and it works equally well for diamonds. Look for areas where gravel and sand have accumulated in a crescent shape. These are prime spots to start panning or sieving. Behind obstacles is another excellent place to search. Large rocks, logs, or even man-made structures can slow the flow of water directly downstream, creating a pocket where dense materials settle. If you find a boulder in the middle of a stream, check the area just behind it. You might be surprised at what you uncover. Crevices in bedrock are perhaps the most overlooked diamond traps. Over time, moving water scours away softer material, leaving behind cracks and channels in the exposed rock. These crevices act like nature safes, collecting heavy stones that get wedged inside. A good crevice tool or even a sturdy screwdriver can help you pry out the trapped gravel and sand to check for gems. When working a river, start by classifying your material with a sieve to separate out larger rocks. Then, use your pan to wash away the lighter material until you're left with a heavy concentrate. Carefully inspect this concentrate for indicator minerals like garnet or chromite. Their presence suggests you're in the right spot. Even if you don't see a diamond right away, these minerals can point you upstream to richer areas. Don't overlook seasonal changes. In some places, river levels drop dramatically in dry seasons, exposing areas that are usually underwater. These newly exposed beds can be rich with material that has been building up for months or even years. Conversely, heavy rains and floods can shift the riverbed, creating fresh traps for heavy minerals. Safety is crucial. Always be aware of water depth, current strength, and weather conditions. A sudden rise in water level can be dangerous, especially if you're working in narrow channels. Good waterproof boots, gloves, and even a life jacket in deeper waters are worth the investment. River prospecting is a blend of patience, skill, and intuition. You might spend hours sifting through gravel without finding much, and then, in a single pan, see that unmistakable flash of adamantine brilliance. It's that moment when a dull-looking pebble in your pan catches the light just right that keeps prospectors coming back to the water year after year. While rivers and creeks are excellent places to search for diamonds, they are far from the only option. In fact, some of the richest diamond discoveries in history have been made far from any flowing water, in areas where erosion, glaciers, or ancient rivers have left behind concentrated deposits of heavy minerals. Learning how to prospect effectively on dry land opens up an entirely different world of possibilities. One of the most promising environments for dry land prospecting is the ancient riverbed. Over millions of years, rivers can change course many times, abandoning their old channels as they carve new ones. These old, fossilized riverbeds often remain hidden under layers of soil and vegetation, but they may still hold the heavy minerals that once settled there. In places like South Africa and Brazil, prospectors have traced diamonds back to river channels that dried up eons ago. Finding them often requires studying topographic maps, aerial photos, and geological surveys to spot subtle ridges or depressions that hint at an ancient watercourse. Eroded hillsides are another key target. When a kimberlite or lamproite pipe weathers over time, the loose material can wash downhill, scattering diamonds and indicator minerals along the slope. By sampling sediment at different elevations, a process known as soil sampling, you can sometimes trace these minerals back uphill to their source. Professional exploration teams often work in reverse, starting with heavy mineral concentrates at the bottom of a slope and working their way upward until they pinpoint the deposit. In colder regions, glacial deposits can be prime hunting grounds. During the Ice Age, massive glaciers scraped across the landscape, plucking up rock and soil, including diamonds, and carrying them for hundreds of kilometers before melting. The mix of sediments they left behind, called glacial till, is a chaotic jumble of materials from many places. Prospectors search this till for indicator minerals, then use the distribution and chemistry of those minerals to walk back toward the original source. Dry land prospecting requires some different tools. A shovel and pickaxe are essential for digging into compacted gravel or breaking apart hard soil. A classifier sieve helps separate out finer material for panning or dry screening. In arid regions, a dry washer, a device that uses air instead of water to separate heavy minerals, can be invaluable. Even without water, you can still concentrate heavy material by shaking and sifting, then inspecting the results for telltale signs of garnet, chromite, or diamond crystals. Another important aspect of dry land work is sampling systematically. Rather than randomly digging, experienced prospectors follow a grid pattern or take samples at regular intervals, labeling each bag with its location. Later, they can analyze the results to identify hot spots where indicator minerals are concentrated. This methodical approach can turn a daunting landscape into a solvable puzzle. The beauty of dry land prospecting is that it can lead to primary discoveries, kimberlite or lamproite pipes that have never been worked before. Unlike secondary deposits in rivers, which have been naturally sorted and concentrated, primary deposits can hold a much larger volume of diamonds in place. They're harder to find, but the rewards can be far greater. In the end, dry land prospecting is about patience and persistence. You might walk for miles under a blazing sun or dig dozens of test pits without finding much. But the next sample you screen could contain the glitter of a diamond that has been waiting for millions of years, not at the bottom of a river, but right beneath your boots. Diamonds have a way of appearing when and where people least expect them, and the stories of their discoveries are as varied as the stones themselves. Some tales are of pure chance, others of relentless determination, but all carry the same thrill. That moment when an ordinary day turns extraordinary because of a glint in the dirt. One of the most legendary finds is the Cullinan diamond, discovered in South Africa in 1905. It was an ordinary afternoon at the Premier mine when Frederick Wells, the mine surface manager, spotted a flash embedded in the wall. What he pried loose was a staggering 3,106 carat rough diamond, the largest gem-quality diamond ever found. Too large to imagine wearing. The Cullinan was eventually cut into several stones, two of which now sit in the British Crown Jewels, a reminder that the Earth still holds wonders beyond human scale. Then there's the story of the Hope Diamond, perhaps the most famous and infamous diamond in history. Believed to have originated in India centuries ago, it passed through the hands of kings, merchants, and collectors, picking up a reputation for bringing misfortune to its owners. Whether the curse is real or just a story spun to sell newspapers, the Hope Diamond remains a captivating example of how a single stone can weave itself into human legend. Not all remarkable finds come from deep underground. In 1975, in the crater of Diamond State Park in Arkansas, one of the only public diamond-bearing sites in the world, a man named W. W. Johnson stumbled upon a 16.37 carat white diamond while casually searching. He named it the Amarillo Starlight, and it remains one of the largest diamonds ever found in the park. To this day, visitors continue to turn up diamonds there, proving that sometimes luck is just as important as skill. In more recent years, there have been discoveries in unexpected places. In 2015, a Canadian man walking along a remote gravel road in the Northwest Territories picked up a small, oddly shaped crystal. It turned out to be a high-quality diamond, transported to the surface by glacial action thousands of years before. His find sparked renewed interest in the area, eventually leading to further exploration and mining operations. These stories serve as both inspiration and caution. They show that diamonds can appear almost anywhere their geological journey allows, from the depths of an ancient volcanic pipe to the shallow gravel of a riverbank. But they also remind us that behind every diamond in a museum case or jewelry store is a journey filled with chance encounters, hard labor, and sometimes sheer luck. Every prospector dreams of their own story, the moment they hold a stone in their palm, knowing it's more than just a rock. And who knows? The next legendary diamond discovery might not come from a seasoned geologist in a far-off mine, but from someone just like you, bending down to pick up a pebble that catches the light in a way no other stone does. Finding a diamond in the wild is thrilling, but the stone you hold in your hand is just the beginning of its story. In its natural state, even a high-quality diamond can look dull, opaque, or oddly shaped. It takes the skill of a master cutter to reveal the fire and brilliance hidden within, a transformation that blends art, science, and centuries of tradition. The process begins with planning. Before a single cut is made, the rough diamond is examined under powerful magnification. Modern cutters also use advanced tools like 3D scanners and computer modeling to study every angle of the crystal. They look for inclusions, internal flaws, fractures, and the stone's natural growth lines. The goal is to maximize both beauty and value. Sometimes that means cutting one large gem, and other times it's better to divide the rough into several smaller stones. The shape of the crystal often dictates the final cut. Octahedral stones tend to become round brilliants, while flat macless may be shaped into princess or marquise cuts. Once the plan is set, the first stage is cleaving or sawing. In cleaving, the diamond is split along its natural grain lines using a steel blade and a precise strike, a risky step, because one wrong move can ruin the stone. Sawing is done with a thin diamond-coated blade or even a laser, allowing more precision. These methods shape the stone into manageable pieces for further work. The next step is brooding, where the diamond's edges are rounded to create the outline of the final shape. Traditionally, this was done by rubbing two diamonds together, because only another diamond can grind the surface. Today, mechanical brooding machines achieve perfect symmetry, setting the stage for the most critical part, polishing. Polishing is where the magic happens. Using a spinning wheel coated with diamond dust, the cutter painstakingly shapes each facet, the flat surfaces that reflect and refract light. The placement of these facets is everything. Too shallow, and light escapes through the bottom. Too deep, and the stone appears dark. A perfectly proportioned cut bounces light inside the gem, creating that unmistakable sparkle known as fire. This stage is incredibly labor-intensive. A single diamond can take weeks or even months to cut, depending on its size and complexity. Precision is measured in fractions of a millimeter, and the work requires a steady hand and an artistic eye. Some cuts are designed to maximize brilliance, others to preserve carat weight, and some to highlight unique features like rare colors. Once the cutting and polishing are complete, the diamond is ready for grading and certification, a process we'll explore in detail in the next topic. At this point, the rough, unassuming crystal you might have found in a riverbed has been transformed into a dazzling gemstone, ready to capture light and attention from every angle. It's easy to forget when admiring a finished diamond in a ring or display case that it once looked nothing like the jewel before you. The journey from rough to brilliant is a collaboration between nature's geological artistry and human craftsmanship. Without the cutter's skill, a diamond remains a hidden treasure. Without nature's work over billions of years, there would be nothing to cut at all. By now, you've traveled the full journey of a diamond, from its fiery birth deep within the Earth's mantle to the moment it sparkles in the palm of your hand. We've explored the violent volcanic eruptions that carried these crystals from darkness to daylight, the rivers and glaciers that scatter them across the landscape, and the subtle geological clues that reveal where they may be hiding. We've talked about the tools and techniques that turn curiosity into discovery, and we've walked through the transformation from a rough, unassuming crystal into a polished gem that can stop you in your tracks. But here's the truth. The most valuable thing you can take away from this isn't just the knowledge of how to find diamonds. It's the way you now see the world. Where others see a gravel bar, you might see a centuries-old trap of heavy minerals. Where they see a hill, you might see the weathered crown of an ancient volcano. Every walk through nature becomes a conversation with deep time. Every stone a potential storyteller. And remember, the diamond you might one day find is more than just a precious object. It's a survivor of unimaginable heat and crushing pressure, a time traveler from an age before mountains rose and rivers carved the land. Holding it is like shaking hands with the Earth's ancient past. You don't need to be a professional geologist to join this adventure. You don't need expensive equipment or years of training. You just need curiosity, patience, and the willingness to look a little closer at the world around you. The next time you kneel beside a river or kick at the gravel along a trail, remember that history's greatest diamond discoveries often began with someone picking up what they thought was just a rock. So here's my challenge to you. On your next walk, slow down. Let your eyes wander over the ground. Notice the glint of light, the unusual shape, the weight of a stone in your hand. Who knows? You might be holding not just a rock, but a billion-year-old story. One that began deep beneath your feet and waited patiently for you to find it. Because out there, somewhere, another diamond is waiting. And the next remarkable discovery could be yours.